Welcome students to this module of e-learning. I, Dr. Maria A. D'Souza, Assistant Professor, St. Xavier's College, would like to present to you this module. To the students of Bachelor of Science, first year, Botany, Generic Elective, paper, Semester 1, paper code BOG 101, and the paper titled Environmental Biotechnology. I will present to you the module number 21, module name Organic, Substituted Simple Aromatic Compounds and Polyaromatic Hydrocarbons under the unit for Xenobiotic Compounds. The outline of the module will be definition, properties of aromatic compounds, types, examples of substituted aromatic compounds, definition, characteristics, examples, sources, and effects of polyaromatic hydrocarbons. Once the student goes through this module, the learning outcomes, he will be able to describe, cite examples of substituted simple aromatic compounds and polyaromatic hydrocarbons. Explain the characteristics, sources, effects of polyaromatic hydrocarbons on the environment. Now, aromatic compounds are simple aromatic rings, simple arenes, simple aromatics. They are known by various names. And once they undergo a substitution reaction, they form substituted simple aromatic compounds. Now, to define aromatic compounds, they are unsaturated hydrocarbon ring structures which have one or more planar 6-carbon rings called benzene rings, to which hydrogen atoms are attached with the general formula CnHn. They exhibit fragrant properties and also unusual stability due to their aromacity. The simplest aromatic compound is benzene, which is the parent compound. And from this, when you have a substituent on that, it is always prefixed to the benzene. Now, these aromatic compounds are named based on the number and the type of substituents on the ring. Very important. Now, let's see the first one. Monosubstituted benzene. That means in these aromatic compounds, we have a single substituent. Now, benzene, whose only one hydrogen atom is replaced by an alkyl or functional group. Now, if this substituent contains 6 or fewer carbons, it is called as monosubstituted benzenes. Examples: chlorobenzene, a Cl is added in the replacement of hydrogen. Then we have nitrobenzene and then bromobenzene. Then we have methylbenzene, ethylbenzene when an ethyl group is attached, and propylbenzene. These are monosubstituted benzene compounds, and if the substituent contains more than 6 carbons, like in this case, we have 1 phenyl octane. But if we have an alkyl group attached or linked to as a functional group to the benzene parent compound, we have benzyl alcohol. Many monosubstituted benzenes have common names like toluene, which is actually methylbenzene, but it is known very much by this common name, toluene. Then we know about phenol. It is actually hydroxybenzene. Aniline, aminobenzene. We have benzoic acid and N-azole. Now we go to the disubstituted benzene. These aromatic compounds are with multiple substituents. Benzene whose 2 hydrogen atoms are replaced by an alkyl or a functional group. And in this case, the ring atoms will be numbered. Now, there are different ways. There are 3 ways actually that 2 groups can be attached to a benzene rings. So, a prefix of ortho, meta or para can be used to designate the relative position of the two substituents. For example, we have two bromine attached here, so it is called as 1,2-dibromobenzene. Then you have again two attached, but in different positions, so we call it 1,3-dibromobenzene. Then we have 1,4-dibromobenzene. With this, we come to the end of the first part of our module. We'll go to the second part, which is polyaromatic hydrocarbons, commonly called as PAHs, also known as other names like polycyclic aromatic hydrocarbons, polynuclear aromatic hydrocarbons. Now, what are these? Let us define them. They are a large group of organic compounds containing only carbon and hydrogen that are composed of two or more fused aromatic rings that share carbon-carbon bonds. Approximately 10,000 compounds are known that are water, atmospheric, and soil pollutants. Coming to the characteristics of polyaromatic hydrocarbons, they are molecules with two or more fused 6-carbon atom aromatic rings. Only hydrogen and carbon are present. They are uncharged, non-polar molecules. They have a low solubility in water, but are highly lipophilic. Very important characteristic in these compounds is this. Higher the number of benzene ring, the pH has a higher molecular weight but lower the solubility in water. So as the number of benzene rings get added, the molecular weight increases, but there is solubility in water decreases. They react with pollutants such as ozone, nitrogen oxides, sulfur dioxide, yielding diones, nitro and dinitro, polyaromatic hydrocarbons, and sulfonic acids. These are some of the examples. We have benzene, naphthalene, anthracene, phenanthrene, pyrene, benzopyrene, coronene, triphenylene. Now, these all have arisen from the parent compound, which is benzene. The first and the simplest polycyclic aromatic compound is naphthalene, having two aromatic rings. It is relatively volatile, soluble, and degradable, an important item in the production of mothballs. Then we have phenanthrene. As you see in the picture, it's having 3 benzene rings. It's high molecular weight compared to the other compounds that you saw. And it's used in the synthesis of drugs, dyes, and explosives. We have pyrene, having 4 benzene rings and forms during incomplete combustion of organic compounds. And it has been commercially used to make dyes and dye precursors. Then we have benzoepyrene, having 5 benzene rings, and it is found mostly in cigarette smoke, and it is produced by the incomplete oxidation of organic compounds in tobacco. When ingested or inhaled, are oxidized to carcinogenic products. Now, the sources of polyaromatic hydrocarbons, they are ubiquitous, found everywhere, persistent environmental organic contaminants generated from either natural or man-made or thermal incomplete combustion of organic matter. You will also find pH in high temperature cooking such as grilling, smoked fish, burnt toast will also form pH in meat and other foods. Burning coal, oil, tar deposits, crude oil, gasoline, trash, wood, tobacco, cigarette smoke, or when biomass burns in forest fires. Also, as combustion of other biofuels such as dung or crop residues, thermal decomposition of organic matter in engines and incinerators. It is a very important source from emissions from vehicles such as cars and trucks. Now, there are a lot of effects of these polyaromatic hydrocarbons. Let's see them one by one. it is released into the environment, they tend to remain in the surface soil and do not migrate in groundwater, except in case of naphthalene. These compounds are said to be pollutants, may also be degraded by some microorganisms in the soil. Now, this is a very important, as I mentioned to you earlier. The higher ringed pH are quite resistant because they have a low solubility in water and they're resistant to biodegradation due to their complexity and very low solubility. They're considered hazardous due to cytotoxic, mutagenic, and carcinogenic effect. Cancer is the primary human health risk. Exposure to pH has also been linked with cardiovascular diseases and poor fetal development. These are the references, students. These are the web links. Thank you, students, for a patient hearing.